Hello everyone, welcome to Brain Blitz Audios. Today we'll be continuing our series on Operation Olympiad. Today we'll be looking at one question from the Grade 8 Max Olympiad. So let's begin then. This is our question. In the given figure, O is the center of the circle, RAB is a straight line, and AQ is equal to QB. The value of 2 times B plus Q is always equal to A. 540 degrees minus 4 x minus 2 y minus 2 z, B. 180 degrees minus 2 y minus 2 z, C. 560 degrees minus 4 x, D. 360 degrees minus 2x minus 4y minus z. So, let's start solving this question. Now, in the figure that that comes with the question, we see that angle RAD is equal to 50 degrees. And it is also on the straight, it's also given that RAB is a straight line. So that means angle RAD plus angle DAB would be equal to 180 degrees. The reason? Both of these are linear pair. Now RAD is 50 degrees plus angle DAB is equal to 180 degrees. So angle DAB is equal to 180 degrees minus 50 degrees, which we get as 130 degrees. So this part is 130 degrees. So now let's look at we are also given that AQ is equal to QB. Now AQ and QB are part of triangle AQB. So in triangle AQB, AQ is equal to QB. Reason? It's given. So this also means that angle QAB is equal to angle ABQ, which is basically these two angles. Mind you, this 130 degrees is for DAB, not QAB. So if QAB is equal to ABQ, because the reason is angles opposite to equal sides of triangle are equal. So which means that angle ABQ is opposite to side AQ, and angle QAB is opposite to QB. That's why both of these are equal. So with this, we can also form the formula that angle ABQ plus angle QAB plus angle QAB plus angle AQB is equal to 180 degrees. Reason is angles of a triangle is always add up to 180 degrees. Now ABQ is equal to QAB, so we can write this as 2 times, so we can write this as 2 times ABQ plus angle AQB is equal to 180 degrees. Now angle AQB is given as y. So instead of writing angle AQB, we'll write that as y. Now if we take y to the other side, we get 2ABQ is equal to 180 degrees minus y. And if we take 2 to the other side, we get angle ABQ is equal to 180 degrees minus y the whole divided by 2. Now is equal to 180 divided by 2 minus y by 2. So if we do 180 divided by 2, we get 90 minus y by 2. So this is how we define ABQ and QAB. So next, let's focus on the 130 degrees we had found. So another angle which we can find is angle DAQ, this part. So this whole angle DAB, which is 130 degrees, angle DAB consists of angle DAQ plus angle QAB. Now if you have to replace the values, DAB is 130 degrees, DAQ is the thing we had to find out, and QAB is the same as ABQ, which is 90 minus y by 2. So if we take DAQ to the other side, we get DAQ is equal to 130 degrees minus 90 minus y by 2. Now so angle DAQ is equal to 130 degrees minus 90 plus y by 2, which is equal to 40 degrees plus y by 2. So this is the value of DAQ. Now since we have to find something related to Q and P, let's look at this triangle ODC, which has something related to both of these. So in triangle ODC, OC is equal to OD, and the reason is radius of the same circle. Now in the question we were given that O is the center of the circle. So that means OC and OD are the radiuses of the circle, and all the radius of a circle are equal. So that means OC is equal to OD. Now this also implies that angle ODC is equal to angle OCD. And the reason is angles opposite to equal sides of a triangle are equal. So if we are to add up all these angles, we get angle ODC plus angle OCD plus angle COD. This would be equal to 180 degrees. The reason is angles of a triangle. So we know ODC is equal to OCD, so we can write this as 2 times ODC plus, and COD we can see that they have marked it as angle Z. So we can write that 2ODC plus angle Z is equal to 180 degrees. Now, if we are to solve this, we get 2ODC is equal to 180 minus Z, 180 minus Z, and ODC would equal to 180 minus Z divided by 2, which is equal to 180 by 2 minus Z by 2, which we get as 90 minus Z by 2. So we get the value of ODC and OCD as 90 minus Z by 2. Now let's look at this angle, because this is similar to this is somewhat in the same area of angle ODC. So angle ADC, this consists, so angle ADC consists of angle ADO, and angle ODC. ADO plus angle ODC. Now ADC is given as X in this figure. They have marked it as X. So ADO, we can write that as ADO since we had to find it out. And ODC we have found it as 90 minus Z by 2. So we get ADO equal to X minus 90 minus Z by 2, which is equal to X minus 90 plus Z divided by 2. So this is what we have found out right now. Next, we can see that ADO is part of triangle ADM. So let's focus on that triangle. So in triangle ADM, angle ADM plus angle DAM plus angle AMD, which is Q as marked in the figure. They have marked it as Q, is equal to 180 degrees. Reason: angles of a triangle. So we have found ADM. ADM is the same as ADO, which is the same as X minus 90 plus Z by 2. And DAM, we have found DAM is the same as DAQ, which is 40 plus Y by 2. So this plus 40 plus Y divided by 2 plus Q gives us 180 degrees. Now if we are to group them up according to some like fractions, so Z by 2 plus Y by 2 plus 40 minus 90 minus 90 plus X plus Q is equal to 180 degrees. Now if we have divided by 2 on Z by 2 and Y by 2, let's make all the numbers in the left hand side like. So we have to have divided by 2 for 40 minus 90 plus X and plus Q. Before that, Z by 2 plus Y by 2, we can write 40 minus 90 as, we can write it as minus 50 plus x plus q is equal to 180 degrees. So you can also, so now we can make all of these like, so z divided by 2 plus y divided by 2 minus, now 50 is the same as 100 divided by 2, and x can be written as 2x divided by 2, and q can be written as 2q divided by 2 is equal to 180 degrees. So we get z plus y minus minus 100, so minus 100 plus 2x plus 2q, the whole divided by 2 is equal to 180 degrees. So if we are to take divide by 2 the other side, we get z plus y minus 100 plus 2x plus 2q is equal to 180 degrees into 2, which is equal to 360 degrees. So since the question asks us to find 2p plus 2q, which is 2 into p plus q, which is same as 2p plus 2q, let's isolate 2q from the rest of these so that we can find its value, and then we'll go on to find angle p. So 2q is equal to 360 degrees. Now if we take 100 to the other side, we get plus 100 and minus 2x minus z minus y as the value of 2q. Now 360 plus 100 is 460 minus 2x minus z minus y is equal to 2q. So this is an important thing to consider. So next, let's introduce you to a new concept called cyclic quadrilaterals. So it's basically a quadrilateral that where its points lie in the sides of a circle. For example, this one, the one I drew, is a cyclic quadrilateral because all of its sides are in the part of the circle. Now the interesting thing about this is that the opposite angles always add up to 180 degrees. For example, if this is x and this is y, then both of these will add up to 180 degrees. So in a cyclic quadrilateral, all the vertices are on the circumference of the circle, so that's why this is called a cyclic quadrilateral. So if we look at this figure, we can see that A, B, C, D is, all the vertices of this are inside this whole big circle, so that means ABCD is a cyclic quadrilateral. And if we look at angle D, or basically angle ADC and angle ABC, according to its properties, this means that angle ADC plus angle ABC would be equal to 180 degrees. So angle ABC is equal to 180 minus angle ADC. Now angle ADC is x, so which is basically 180 minus x. So to now this angle ABC can be divided into QBC and ABQ. So angle ABC is also equal to angle ABQ plus angle QBC. So angle QBC would be equal to ABC minus ABQ. Now, ABC, we just found out, is 180 minus X, and ABQ, we have found it out at the beginning, is, so ABQ is the say we got it as 90 minus Y divided by 2. So we can write it as QBC is equal to 180 minus X minus 90 minus Y by 2 inside brackets. So if we take it out of the brackets, we get 180 minus X minus 90 minus plus Y by 2. This seems QBC. Now 180 minus 90 is 90 minus X plus Y divided by 2. We get this as the value of QBC. Now we've looked at one pair of opposite angles of quadrilateral ABCD. Now let's look at the other pair of opposite sides, which is DAB and DCB. Now we have found it out at the beginning that angle DAB is equal to 130 degrees. So this means angle DCB would be equal to 180 degrees minus 130 degrees, which is equal to 50 degrees. The reason is quadrilateral ABCD is cyclic quadrilateral. So we get the value of DCB as 50 degrees. Now this angle DCB can also be divided into OCD and BCO or BCN. So DCB is equal to angle OCD plus angle BCN. We just now angle DCB, we found it is 50 degrees, and angle OCD, we had found angle OCD as, now OCD is the same as ODC, which is 90 minus Z by 2. So if we replace the values, we get 90 minus Z by 2 plus angle BCN. So that means angle BCN is equal to 50 degrees minus 90 minus Z by 2 in the brackets. So we get 50 minus 90 plus Z by 2 is equal to Z by 2 minus 40 degrees. So angle BCN is equal to Z by 2 minus 40 degrees. Now if we look at this triangle BCN, this small triangle, and if we extend side BN, we can see that angle P is basically the exterior angle of angle N. So by the exterior angle property suggests that the exterior angle of a triangle is equal to the sum of its non-adjacent sides. So angle P would be equal to angle B plus angle C, angle NBC plus angle BCN. Now, so P is equal to angle NBC plus angle BCN. The reason, uh, exterior angle property. Now if we replace the values, NBC is the same as QBC, and we found that QBC is equal to 90 minus x plus y divided by 2, and BCN, we found out that it is z divided by 2 minus 40. Now if we are to rearrange them, we get y by 2 plus z by 2, y by 2 plus z by 2 plus 90 minus 40 minus x as the value of p, small letter p, not capital P, small letter p. So just like we did before, let's make all of this like fractions. So before that, y by 2 plus z by 2, 90 minus 40 is 50 minus x is equal to p. Now we get y plus z. Now 50 can be written as 100 divided by 2, so plus 100, and minus x can be written as minus 2x by 2, so minus 2x, the whole divided by 2 is equal to p. So that means 2p is equal to y plus z plus 100 minus 2x. Now we have found the value of 2p, and we had also found the value of 2q, and the question is asking us to find the value of 2 times p plus q. Now 2 times p plus q can also be written as 2p plus 2q, so which we found out. So 2 times p plus q is equal to 2p plus 2q. Now 2p is y plus z plus 100 minus 2x, and 2q, we had written 2q, found out that 2q is 460 plus 460 minus 2x minus y minus z. Now if we solve it, we get 460 plus 100 plus y minus y plus z minus z minus 2x minus 2x. Now 460 plus 100 is 560, plus 6 and minus y cancel each other, plus z and minus z cancel each other. We get minus 2x, which is minus 4x. So this is the value of 2 into p plus q, 560 minus 4x. And we can see that option C says 560 minus 4x. So this is the correct answer for this question. That's all, folks. We hope you found it interesting. For more such useful videos, please subscribe to our channel and hit that bell icon. For more, until the next video, take care, stay safe, bye bye for now.